The second important value is the effective sample size. You will remember this is the sample size that we would use if we were doing a simple random sample. How do we calculate the effective sample size? Well, if we're talking about a survey for estimation, then we have to elicit three quantities from the steering committee. First of all, what do you think will be the outcome of interest? What is the vaccine or the outcome that we're most interested in powering the survey for? For vaccination coverage surveys, it's often for Penta-3 or DTP3. For a post-campaign survey, it's usually for, say, coverage of measles vaccine in the campaign. So we have to select a primary outcome of interest, and then we ask the committee, well, what do you expect the coverage outcome to be? This seems a little counterintuitive because if we knew the outcome, we wouldn't have to do the survey. But the committee, they will have an idea of what coverage should probably be, and they'll be able to give you a response. And then the next question is, how much precision do you need? Or how much imprecision can you live with? What is the widest confidence interval that would still be useful to you, dear committee, if coverage is at the expected level? And so in the Burkina Faso example, we might say that we're going to do a measles SIA coverage survey. There's been a vaccination campaign, and we're going to check and see, did they achieve 95% or not? So the primary outcome would be SIA coverage. The target coverage would be 95%. And we would like to have a confidence interval that is no wider than plus or minus 5%. Then there's a table in Annex B, it's called Table B1, and we can just look up the effective sample size in this table. So since we know that our expected coverage is 95%, we're going to be working in this column. And then we know that our desired precision is plus or minus 5%. So we're going to be working in this row. The intersection of this column and row is the value 162. So the effective sample size for that survey would be 162 respondents. Now, if the goal of the survey is classification instead of estimation, then the quantities are a little bit different. In that case, again, we ask the committee, what's the primary outcome of interest? What is the programmatic threshold? We ask them to specify a second coverage level where they want to confidently classify coverage. The difference between the programmatic threshold and the second coverage level is a quantity that we call delta. And then if the second level is higher than the first, then we have this quantity from the tables that we call direction, and direction is either above or below. So if the second level is higher than the first, then direction is above. If the second level is lower than the first, then direction is below. And then we ask the committee, what level of confidence will you use to do your classification? The common responses are 95% or 90%, and those correspond to a quantity alpha. And alpha is then 5% or 10%. The smaller the alpha, the more confidence you have, but the bigger the sample size you'll need. And the last question that we ask them is, if true coverage is at least delta points away from the target, then how frequently would it still be acceptable to misclassify the coverage with this survey, to make a mistake in the classification? So let's look at an example. In the SAA survey, the coverage target is 95%. That's the value of the threshold. We say we want to be very sure that we will identify zones where coverage is below 90%. Well, 90% is the second coverage value, so delta is the difference between 95 and 90. Delta is 5%, and the direction is below, because the second coverage value is below the target. And then we say, if the true coverage is below 90%, we want to be sure there's at least a 90% probability that we're going to classify that stratum. We're going to classify coverage there as failing. Now, the fact that we're using 90% probability, that means that beta is 10%. And then we're going to use a 95% confidence bound. And so the fact that it's a 95% bound, that tells us that alpha is 5%. So that's one example. We have a second example here. If we said the primary outcome is Penta-3 and the target is 85%, that's our threshold value. We say we want to be very sure that we're going to identify districts where coverage is above 90, and that we call those, we give those that we give them a classification of passing. So we see right away that, again, delta is 5%, and in this case, the direction is above. Now, if coverage is higher than 90%, then we want to be sure there's at least an 80% chance that we're going to classify that stratum as passing. Well, if you want 80% power, then that means your beta is 20%. And if we're going to do the classifying using a one-sided 90% confidence interval, that means alpha is 10%. You take this information and then you turn to table B2 or table B3, depending on whether direction is above or direction is below. And you use these values to look up the estimated sample size in those tables. Alternatively, you can enter those values into Dana's spreadsheet, and the spreadsheet will calculate the effective sample size for you. We'll see some examples of that in our time together on Tuesday.